In part B of this question, we are asked whether there must exist a value of c such that on the 60 to 120 interval, there exists a point c such that its derivative at that point is equal to 0. So what we need to remember here is the mean value theorem, which states that any continuous differentiable function on a closed interval will contain a point that is equal to the derivative of the slope connecting the endpoints of the interval. So what that means, in this case, our endpoints of the interval are at 60 and 120. So the line connecting the point from 60 to 120 will have a slope of the function value at 120 minus the function value in 60, so the change in y, and we divide this by the change in x, 120 minus 60. Now if we look at the table, this will be 0.1 minus 0.1 at the top, so this will be 0. Therefore, what this says is that since the line connecting is a horizontal line, there must exist a c such that f prime of c is equal to 0. So we can say by the mean value theorem, there is a c which is in between 60 and 120 such that the derivative of point c is equal to 0. This might also be referred to more commonly as Rolle's theorem. Rolle's theorem states that if we have a continuously differentiable function and the start and end points of a function are on the same level, so for example like this, then there must be at least one point in this interval where the tangent is horizontal. So this is always the case. This is known as Rolle's theorem. This refers to the case when the y coordinates are the same for the starts and ends of the interval. In this case, that is the case.